plans for the treatment, the boric treatment, etc. that the tannalized treatment, sorry, that they put timber through. They put it in giant kilns, they treat it with chemicals, etc. Pretty much protecting the timber from the weather. It doesn't last forever. You look around Auckland, some fences look really good. They've been there for 10 years. Other fences, been there 20 years, they're starting to rot. Because eventually, like anything, the weather gets in. So yeah, we'll talk about the H factor as well. And then there's the nominal factor. So when you go into a timber yard and you say, oh, I want 100 by 50s, that's 100 mil by 50 mil. So it's 100 that way and it's 50 that way, right? Easy to understand. But then they say, do you want rough sawn? Do you want gauged? Do you want smooth? And you're like, hold on, I didn't know there was a difference, but there is. And when they start talking about smooth timber, I'll tell you in my notes, the size comes smaller. So if you're looking at decking boards, for example, most decking boards are 100 mils wide. So if it's 3 meters wide, you'd think, well, 30 decking boards, right? You lay them all out when you get home, and you've got a bit at that end that's missing. Because the decking boards aren't 100, they're 92 to 93, 94, around about that. So every time you put one down, you're 6 mil short. By the end, 6 times 30, you're short 3 or 4 decking boards. And construction, that can be a bit of an issue. If you're cladding a house in weatherboards to the top, and you're one weatherboard short, the house is going to get pretty wet, isn't it? From the gap that's left there. So, if you've got structural members that are meeting on a ridge board and you've not taken that into account, you've got a short ridge board, then there's nowhere to fix it to. So you've got to talk about rough sawn, smooth, gauged, etc. And I'll talk about that. I'll also talk about fixings for timber. It's quite different to steel. When we fix timber together, we either use things like tooth connectors, where they look a bit like something from a science fiction movie that blocks together and stops it from moving both ways. You've got gang nail plates, which are pretty much just things you slap on the side of a piece of timber, and then they've got their own little nails on them, and they hold 2 bits of timber together. You'll see them on trusses. You've got things like anchor plates, which you put on the top of piles to hold houses down on piles. And then you've got my favourite one, which is Z nails to hold piles down. They also work really well when water races annoying you on the street, because you throw them out in the middle of the road, and they always have one side will be pointing up like that to take their tyres. Not that I've ever done that, right? I find that a pole thrown at them is just as good. Strange, always people that were boy racers end up being the ones that get most annoyed at them when they get older. Funny that. So the Z nails, and then lastly I can show you a couple of things on details as well. And for those that are awake, you might find there's a couple of bonus half marks to be sought along the way. But if you want to just quietly drift off to sleep, that's fine as well. That works just as well. Okay, so I'll save my notes, we'll get into them. The timber notes are going to be very helpful with assignment 4, because you'll be calling up all those timber members on the truss. I don't want to see a table like I've got with the letters K, L, N, N, O, P. I want to see you thinking about how you call them up. And thinking about words like I told you last week, handed. Handed is a very easy one to remember, because it means it's a mirror image. When you've got 2 hands, that hand is a mirror image down here of the other hand. So when something's the same on that side, you can call it up once and call it as handed. H-A-N-D, E-D in brackets. It means it repeats on that side. Okay? You can also use typical. if there's a typical connection that's all over the truss, you call it up once over here and call it typical. Done. It's a time-saving thing too, because nobody wants to be going and putting notes absolutely everywhere. Another thing is to say refer to note 6 in brackets, typical, and over in note 6 you've got a big long description of what you're talking about. Done. Right? So it's that cross-referencing thing going on as well. As far as the test goes, we've got 3 multi-choice questions will come out of today's notes. Every now and then I'll stop and say that's one of the questions. Okay, so that's a bonus for you as well. And there are 2 diagrams which I'm going to stop at, and I've also got 2 questions out of that 2+ questions. I think there might be 3 or 4 in some cases. So I've told Moodle, hey Moodle, take 3 questions from the structures, and I've got about 20 of them roughly. Moodle will choose you 3, and I've told Moodle to take 2 or 3 questions out of these diagrams I'm going to show you. The diagrams are a cross-section of a house. The house is got all the members labelled. If you've had anything to do with construction, you'll know quite a bit of it. You'll be quite pleased about that being in the test. If you're new to New Zealand, some of the terms will be a bit weird. If you've only lived in Auckland, they'll be even weirder, because there's one from the South Island, where I come from, which I will make compulsory to learn. In fact, even worse, it's south of where I come from, where the locals roll their R's and they talk about funny things. But it's actually, if you end up doing engineering south of Dunedin, you're going to go on site and someone's going to say this word and you're going to go, what the hell? Because Aucklanders call it a totally different word. I'll talk about that as well. So if that hasn't got you all excited, like it's got me excited, then in a couple of seconds we'll rip into it. So I'll just save the notes and we'll get into it. I hope you all went to Ingrid's revision class and took lots of notes, because like most lecturers, that's the way how you learn for a test, first up. But I didn't tell you that. Oh, the assignment, if you've copied it and printed it, I revised sketch 2 a little bit today. So not that much, but it's enough that you should print it out again if you do it by prints. There was a slight mistake on where the ground line was. So I've changed that, so I've just moved the ground up a little bit so that it matches sketch 1. It won't, it shouldn't affect anything, but I just want to tell you that so that you can have another look at it before. The only thing it might affect is your earthworks, your excavation, so just have a look at the latest before you do your excavation cuts, okay? I'll make this available in a second for those who've got laptops. Just looking at the camera, just noting that the person who's taking the film is slowly starting to fall asleep. Oh dear, that's on the internet now. That means he's not going to upload it. wk10. And there's a slight change to the program as well. I won't be doing the 3D in the lab today. I'll do it next week. There's plenty of time to do that. If you want to proceed on with assignment 2 and the holidays, you've got plenty of work to do with the 2 elevations and 2 details as well. Okay. We finish somewhere around here. Up here, I think. Right. So the revision class by memory, I'll just make sure it's correct on your timetable. Don't miss it, because I'll be going over things that you'll need to know for the test. And I don't know when I'll be able to upload the video for the class. Week 1, is it? No, it should be up here in the timetable. You want to see it? Oh, there it is. Okay, so yeah, well that's quite good. You actually get a lecture break of 3 weeks from me. So that's for some of you that's an absolute bonus. For others, you'll be crying into your beer while you're not at my lecture. The 3D in the lab will be here. Don't miss that. That's my only demonstration of it. I've decided this year I'm going to actually do the assignment. So I'll be demonstrating the actual assignment and what I would do to do the 3D. You'll find with the 3D commands, you won't necessarily do it my way. I'll just show you a way, but you'll get kind of going, oh, why don't I do this or do it that way, etc. And then you'll have another whole week, the following week, to carry on with your drawings. And also a revision lecture that you really shouldn't miss, this one here. Alright? I'll send out a little reminder that there's no lecture, but you'll only get one, otherwise you'll be the only person sitting in here on the Wednesday morning looking, going, oh, bloody lecture, he's never here. Right. Week 10 notes. So I gave you a bit of an intro to this. We talked about the species. The very first thing you need to put into your notes is whether it's Rimu or radiator pine, which is the New Zealand timber that we normally put. As an example, often decks in New Zealand are hardwood, and they often, there's so much choice now, there didn't used to be. Fijian Quila is a very popular one, and there are many other hardwoods now that are turning up from around the world. Don't know how much longer that's going to be sustainable after the forests have been on fire, but anyway, hardwood is something that's often used on things like decks. Hardwood is very rarely used in construction, engineering construction. Tend to use radiator pine that's been treated.
Why?
It's the cheapest and it's got the same strength abilities. Yeah. Different if you like in America and Canada or Alaska in the middle of nowhere, you're going to chop down whatever tree you've got to build your house. But this, we're talking about domestically and commercially in New Zealand. Moisture, the grade of the timber, we'll talk about that later on. And generally, timber will conform to New Zealand standard 3631. Moisture content. You'll learn this as part of materials, and it's quite an important note. I'd like you to put this note on the drawing that the moisture content should be between 14 and 18% before you can continue building anything internally in your building. In other words, they can't fix the drywall or what we call a New Zealand jib. You can't put the jib on the roof. Also, that's a multi-choice question. along with the fibre saturation point, which is when timber reaches a point of the maximum wetness that you can actually use it for construction. It can go above that, but anything more than 26 to 30, and it starts becoming green timber. So often when they're sorting through timber on a stack to use, the timber's starting to turn green. It's often a good indication that it's gone past the fibre saturation point and probably shouldn't be used in construction until it's been dried out more. Once again, the splice joint is for lengthening, not strengthening. There's the lintel, the tie and the strut, which you should know by now from my steel notes. General scales for doing timber construction are very similar to most of the other drawings, 1 to 5, 1 to 10, 1 to 20, 1 to 50, 1 to 100. You'll be required to do a scale of 1 to 5 for both of your details. Please do that. Sorry, there's a bit of repetition here. I've put a chart here, much the same as I put a chart for the steel. Do not use it for your assignment. What the chart does is it indicates that before you do any timber construction, you should consult with your local timber yard to see that they've got the sizes that you need. In fact, going right back to when you first do the design, it's a good idea to find out what's available so you can work a design around those member sizes. No use doing it and then finding you've got to wait for another shipment to come in, which could take, another 2 or 3 months from overseas or wherever. So it puts a big hold on your building. You'll notice the likes of 100 by 25s, 50s, 75s and 100s are quite a popular size. Normally, if you do things out of that, they're available most of the time. You have got some joints on your truss, so you should take note of some of the notes here on the split rings and how they're drawn up sideways. You've got a centre line through here with a circle, and sideways they look a bit like that, where the bolts at each end draw the bits of timber together. Shear plates, generally put in place to stop the timber from moving in this direction, whereas that mean looking one at the top there, the tooth ring looks a bit like this. It kind of digs into the timber, stops it from moving in all directions. Okay, underneath buildings, we generally tie down the posts with these Z nails, which is what I was talking about before. You ever find one of them in your tyre? It's probably been me that's put it on the road. Here is that's not true by the way, for the camera. For the framing anchor, when we do piles for a domestic house, for example, an engineer will work out where we need to put our anchor piles. So normal piles are about 400 deep in normal circumstances, and in a grid of about 5 metres approximately, you should have an anchor pile which will go down 1 to 1.5 metres. Kind of locks the house further into the ground. So you'll have a grid of those every 5 metres, which is quite a lot, and all the others will be small piles. On top of every anchor pile should be one of these fellas here. It's called a framing anchor, and they're screwed into the timber, and with the bearer and the joist, and also there's another type which is screwed into the piles. These ones at the top here, which are gang nail plates, they are flat pieces of steel with their own little, they've got as many as 40 little nails in it that bend out of the steel, and you hammer them into both steel members, and they can hold together as many as 4 or 5 timber members at any one time. They're very common to use them with a press to put together trusses. It's not uncommon for diploma engineers to get a job working for the likes of Fletcher's or whatever, drawing up these trusses and getting them made up and fabricated in the factories. I was talking before about rough sawn, gauged and dressed. Now, rough sawn is basically the first cut that goes through with the big blade through the tree. And it comes out all furry. You can tell rough sawn timber, it's kind of furred on the side. And it's often nominal size 150 by 100. Sometimes it's a bit more than that, depending on how the saw goes through the tree, bumping up and down as it's going through. Gauge, they tend to take the rough sawn timber and they'll put a fine saw through it, and it'll be a lot more closer to those dimensions there that are on the page. So you can see already we've lost 6 millimetres on both, right? But it'll be a lot smoother, and often you can paint gauge timber, whereas rough sawn, I don't know if you've tried to paint a fence post before, and the furry bits all get in the road of the paintbrush, and it's very hard to make it look quite nice. Whereas if it's got a nice flat surface from gauged, it's even. And dressed timber is more the type of timber you might use for furniture, a table, or a very nice finish to, say, a balcony on a house. And as you can tell, you've lost 10 mil just to get that down to a very smooth finish. I would suggest we'll be using rough sawn. I don't think the caretakers are going to be looking up at the roof too much and getting too worried about it not being sawn, not being painted. It's easy, it's the cheaper, and you'll make just as good a job to keep the tractor nice and dry and any of the other bits and pieces that he stores in there.
Trusses are usually made specifically by a company. Like, you can't make them yourself. They're engineered trusses, so more likely to be gauged, wouldn't it? Because would a rough sawn not be as accurate, like 150?
I'm happy to use rough sawn timber. I haven't specified that it's coming from you say always, they're normally made by a prefabricated company, correct? And that's just the way the building's moved on these days. Builders don't tend to put those things together themselves. They just order them and bang, bang, bang. Yeah, if you want to put that it's prefabricated, you can drop it down to a gauged if you want to. Everybody understand that? You can put gauged for the truss if you want to. But you would have to specify the company that's making it, I guess. But I would be happy at this stage if you wanted to just make it out of rough sawn timber, assuming that the builder was putting it together themselves. This, you have to realise that this assignment is fictitious. I'd like to think it was exactly what would be built, but the reality of a maintenance shed would probably be one of those cheap things that Unitech could afford, made of tin with tin posts and things sitting in the middle of the park over there. It probably will be close to the road somewhere and miles away from the site that I've put it on. But I've chosen, I get a brief from NZ BED board, which is the people that control your assignment. And they're governed by the Dublin Accord. So it's a worldwide qualification, and they say that I must do an assignment that has got either a platform or a road, so you understand design contours. It must have other things in it to make it something you can talk about it, like environmental, siltation, earthworks, etc. because that's all part of civil engineering. And then they move on to structures, and they pretty much tell me that I need something with concrete, steel and timber. Right, so I'm kind of bound by that. I guess in order to bring in things like rough stone, radiator pine, 3 point something, H factor, I'm sort of thinking it sort of has to be put on site by you, right? Or by a builder. So I've justified my existence, but I do apologise if it's a little bit out of the realms of reality, the actual program. The degree students get a chance to criticise it, you guys don't. They do a design report, which they've just handed in, and I've told them to go for it in the last paragraph over what they think a good alternative would be. And most of them have a good chance to diss their lecturer and come up with a better idea. Okay, that's fine. Please don't put that in your notes. I'll have a laugh, but then I'll have a look at the deduction column as well. You got that, Jimmy?
Yeah.
Okay. Yeah, this is another one of those for information only columns. It's always a good idea to check with your local timber yard to what the finished dimensions are of something. You order smooth, get the guy on site. They walk around with their tape measures like their guns on holsters. Get them to walk around and do a quick measurement for you before you turn up to make sure that the finished dimensions are what you're expecting. Okay, I guess the easiest way to explain this is that when you slice through a bit of timber, if it's a little short bit of timber, we call that a block. Now where you might find a block is, excuse my sketch, but you've got a wharf, let's call it the wharf down at the viaduct, and you've got these little blocks every now and then on top of the decking board. Let's put them on top of the decking board, not behind the decking board. Okay, and they sit there like this, and then on top of that is a continuous member sitting on top. So what it looks like in profile is you have your continuous member on top, your block, and then you've got your decking boards, you've got your bearer coming over here and your piles coming down here. And what you tend to do is you put the rope around this piece here to tie your little boat. Which way around the boat can go? Let's call it something like that. Yeah. Here's my wee boat sitting in the water, and you're tying it up around there like that. So we have a block, we have a continuous bit of timber along there to tie it on to. You've all seen that when you've gone for a walk around the viaduct in Auckland. The question is, how do we hatch that to show that one's a block, just a small piece, and one's continuous along the wharf? Well, the continuous member is hatched like that. The block is hatched with a single line. If that was dressed timber, which is the really flash stuff that you paint, you'll use that there. So you may have a situation when you're looking through the truss on your assignment 4, where you may have to figure out, hold on a minute, I've just gone through a short piece. There is a couple of short pieces there, just on this, that are holding other bits of timber together, and you may need to use a blocking, whereas in other cases it'll be a continuous member when you go through.
But this area of framing, you know, they use like a packer, and that's basically a block, isn't it?
Packer would be a block. Yep.
Okay.
So, yep. So if often when you're doing a house, you have to show sections through the house,
Yeah.
and that would indicate that that's just like a packer or a block used. A good example would be when they put in door frames and window frames. They never fit perfectly, they've always got some slack. You put it in and they'll put a little wedge in there. Wedge is another one. Yeah.
So they draw the wedges the same way.
I guess if you're going to put a wedge in there, yes. Generally speaking, they don't, and architects don't allow for wedges. They expect it to be perfect, that the builder knows otherwise. Here's a sideways view of the thing I was talking about before. Some of these jointers that are used on the wood. This is the wood member here. This is the ugly looking teeth that fit together, and there's the other piece of timber on the other side. Note the washers. Anywhere where you're using bolts on timber, you should use a washer. Generally speaking, a washer is 2 times the diameter of the bolt in size, the circle. And you should use a washer, and that should be part of your schedule that you're handing in this week, in 2 weekends time, not this weekend, the following weekend. I was asked the other day by a student, how do we do our schedule? I'm giving you a license to do it whatever way you want in terms of nuts, bolts and that sort of thing. So if you want to put your nuts, washers and bolts in one schedule, that's fine. You can even put the Dynabolts there if you want to. But generally, I would put the Dynabolts with the concrete because they drill into the concrete, or the steel because they're going through the steel plate. If it's a steel on steel bolt, probably should sit with the steel as well. But I'm not going to mark you down for it. If you want to put all the nuts, screws and bolts together, that might be something that you're okay with. I generally find that when I'm scheduling something, I tend to put it with the things that they go in, and then I don't forget something. So I'll go, right, the Dynabolts are going into the concrete, let's do all the concrete quantities, let's put a Dynabolt over there, now I haven't forgotten about that. Okay, let's do the steel, okay, we've got a bolt here and a bolt there, let's put those bolts with the steel, and now we've got all the timber, and we've got the bolts for the timber, and you add them up, and then you generally don't forget. I've seen students do this, they think they've got 100% in the schedule, and they've forgotten about bolts just because of that. Yep.
Is it a good idea to do a hardware schedule on Excel first? And do like every bolt, it just automatically puts in a washer, 2 washers.
Yeah, it's not a silly idea. Just be careful. It's kind of you're duplicating, but it's not a dumb idea. I tend to do the steel one on Excel because it'll give you an answer along, it'll multiply all out. But the problem with putting that into your drawing is that your text types might go wonky, so you lose half a CAD mark for getting your text types when you don't need to, right? That's another question. What scale should I do my my schedule and reinforcing schedule? The answer to that is if you make it 1 to 20, you can keep the same text types as you've done your reinforcing plan. The title block appears to be the wrong one for A3, A1, sorry. So you may need to scale up by 2. Please, if you haven't put your title block in by today's lab, at least have a go at doing that before you come in tonight or tomorrow, so that if you're having trouble, I can help you this time, all right, or the past student can. Generally speaking, students haven't done the ACAD thing. You go File, New, ACAD, and then you set the A1 full bleed, and then you change the units, very important, and the title block would be about that size, down on the bottom of the sheet, stretch it out and put in the title block. What other question? Oh, someone said, should I use AutoCAD tables? But you don't have to. A lot of people think it's neater and tidier. The problem with tables is you're always adjusting them, and the adjustment's a little bit of a pain in the butt. And whereas if you did your own little lines, you can get it reasonably neat and tidy yourself. But if you want to, use it, make sure you get the right text on it. That's what I'm saying. And that will require some notes. The schedule, as far as the notes go, any notes on your plan view of the reinforcing should be about concrete and reinforcing, nothing else. Nothing about the steel, nothing about dynavolts, nothing about what my lecture is today in the timber. Just concrete notes on there, and I'm expecting 7, like I have on every minimum. Alright? On the main quantities and reinforcing drawing, you can start adding notes about timber, you can add notes about steel, you can, once again, I only want 7, but it's your opportunity to start putting some notes in from my lecture notes as well. It has a twofold effect. Students that put the most notes get the highest marks in the test, because they've gone through the notes, read them, put what they wanted in the drawings, and it's already in their brain a bit. So when the test comes around, they find the test reasonably easy, rather than to revise it all the time. There's some examples of drawings, and we've got examples of how we detail bolts on timber. Now that is a centre line and a circle. So if you're showing bolts on timber, that's exactly how I would like you to detail it. This is assignment 4, by the way. And I know it's easy just to put that on your brain, but it's a good little, where you have got a situation where you have bolts lined up in a row like that. A coach screw, you do have a coach screw. It goes through the angle and into the purlin. So your coach screw if it's shown in this view, now this is a vertical one, you've got a horizontal one. So this would be your horizontal way of showing it, a line either side with a centre line. And this will be your way of showing it sideways. With timber, we drill the hole the same size as the bolt. You don't have the 1 mil like you do with steel. And then we basically bang the bolt in so it's in place. Nails. This is how we show nails with timber, with a cross. Okay? We generally don't call up all the nails. We generally will put a centre to centre of one of the nails and leave it up to the builder to put the nails in at required centres. Bolts. These are a good example of a coach bolt, which would be used on timber, but generally speaking, you would also use a washer on both sides. If you don't use a washer and you tighten it up, it's only going to pull itself into the wood. Wood's very soft. It's just going to go into the wood and start disappearing.
It will damage the wood as well.
Beg your pardon?
It will damage the wood as well, isn't it?
And it can damage, you can split the wood. Yeah. The washer tends to keep it really tight, but it doesn't, only the washer goes a little bit into the wood. Yep.
You wouldn't have a washer on the
On this head here,
side, would you? That's the reason.
that's the reason for that, yeah. So you could get away without a washer on that side, but generally I would put one in anyway. You can't have one here, no, because the nut is stopping it, yeah. This is for recess, by the way. They drill a hole right through that size and they recess a hole that, so that the nut fits in the recess.
You just smash it in, don't they?
That's another way of doing it too, I guess. Engineering bolts. I would suggest that on your assignment you're mostly going to be using engineering bolts. Coach screws. You do have some coach screws. What I'd like to point out here is that when we call a coach screw up, you're going to have to call up the length. So on your assignment 3, don't just put 125 6 diameter coach screws, or 10 or 12 diameter, whatever it is. Put the length, and the length is not the screw length, the length is from here to here. And I would suggest it would be pretty ugly if it went all the way through and out the other side. So have a look at the member that you're screwing through, make sure it doesn't go too far. There's a bit of a chart for you to work out some of those lengths. Nails. Here's a strange nail for you. Looks like one of those Lord of the Game of Thrones swords, doesn't it? Exactly. What would I use that nail for? Don't be shy, it's worth half a mark.
Kill the Night King.
Is that?
Nothing.
No? Nothing? Game of Thrones? No? So this, let me remind you that after 2 years here of study, you're supposed to think laterally as engineers.
Oh, so it's easier to pull them out later?
That's dead right. Yep. But unfortunately, that's only worth a quarter of a mark.
Oh,
What would you use it on then in that case?
temporary fastenings.
Yes. Example. I'm making him work for it. Oh, he's trying to get his half mark as well.
Plywood.
Possibly.
Battens.
You've done enough, but if you go back to my drawing here a few weeks ago, and we had the concrete retaining wall, and we had the formwork and the false work. That's what they do is they put that into a nail gun, they'll shoot it in, bang, and they go along. And that just leaves enough left out that the guy with the hammer can come along and pull the nails out really quickly and move on to the next bit of box. The only, I don't know, Jimmy, you've got till 12 o'clock tonight to email me, otherwise use it or lose it. If you've already got one answer already, then your maximum is half a mark. So I'd like you to answer this one so no one else gets it. And I'm hoping one of my island students gets this one because it's very relative. No pressure. Either the angular grooved or the spiral rolled. Where would you use those? And why did I say island student? Embarrassing if you're an island student and you can't get this right. Give you guys dibs first if you like. Can you think? Where would you do that in construction? Do you know what one of them said to me in the degree class? To hold the washing machine down. Not in the washing machine, to hold the clothesline down so the sheets don't blow away or something. And I said close. Anyone else?
Cladding. Cladding.
Cladding, yeah. More specifically, roof cladding.
Yeah.
Why would you put it on the roof?
Because the spiral roll is extra strong to hold the roof down.
From a possible. Oh, close. Come on, I'll give you last chance. What would remove the roof in the islands?
Wind.
Windy.
Wind.
He's done enough. I was just making him sweat for it. Okay, that's a popular type of nail used over there to hold the roofing iron down, obviously for cyclones. I don't know where you guys come from, but they, about every 3 or 4 years, they tend to get direct hits in populated areas. And yeah, the other one, they do have screws as well, similar, but yeah, I guess the cyclones tend to come a bit more closer to Auckland these days, so before midnight tonight, all right? Okay. And as promised, just to end the lecture, these two diagrams here, I'm trying to get them blown up if I can. No, I'll roll that back a bit. Can you see that? Not too bad. All right. I want you to memorise these. I want you to put them in your memory bank. I want you to go over and over them. I want you to sleep with them for the next 3 or 4 weeks before the test. Because they are building terms that if you ever go on site as an engineer, all you're going to hear is those terms from builders, and you really should know them. I'll give you some examples why, but in the meantime, this is the South Island one. Dwayne, funny name. Aucklanders call them nogs, N-O-G-S. And then the bits of timber, when you see a framing on a house, they fit between the two studs. So anyone in the North Island is used to the word nogs, and they'll just look at you strangely when you say Dwayne. If you're from the South Island, they mostly call them Dwaynes. So that's an interesting one in itself. DPC, damp proof course, that's a piece of malthoid that stops the water or the dampness coming up from the concrete to the bottom plate, or the plate, sorry, not the bottom plate, that's the bottom plate there. There's an example of a bit of blocking between the bottom plate, the plate and the bottom plate. Rafters, ridge boards, ceiling joints, top plates, studs, floor joists, etc. Up the top there, in more of a commercial building, they talk about things like sarking on the roof, knee braces, sheathing to girts. Girts is also a multi-choice question as well. Girts are little like lugs on the side of the building which hold the sheathing or the cladding onto the building. Purlins, roof trusses. So what I've done is I've duplicated those drawings, and instead of the letters, the names, I've put like A, B, C, D, E right the way around, and you'll see the same drawing appear on everybody's computer screens, but I'll say what is F, what is E. So
multiple choice or?
no, it'll just ask you for one of the letters randomly. Yeah, you won't be. You might have the same drawing up, and you get asked for E, and he gets asked for Z, and he gets asked for A. Okay.
How many questions are we gonna get from this?
Minimum 2, maybe 3 in that one. That's it. That's this one here. I put 2 plus. I can't remember exactly what I told Neil. Multi-choice 3 from there. So it's quite a big chunk from the structure this week. Out of 20 is about 5 or 6 questions. And this is in here. This was very interesting for a couple of years ago when we did a bridge, and I wanted a cutaway deck. That's how they often show decks on houses and bridges and piers, by showing a little bit of the decking, and then they have a piece cut away so you can see what's underneath. For you guys, just information only, okay? Just like these sectional views are. Now you will be required to do 2 details. You don't know what they are just yet, and you're about to find out. The 2 details that I want you to draw up for assignment 4. Get rid of my Game of Thrones sword. The 2 details are the detail of the connection to the purlin with the angle there, so that one, and the other one where the
Is that a truss to purlin?
you trust to, there's an angle here, that's the angle there, and that's the purlin,
And that's the truss.
and this is the, well, it's part of the truss. Yeah, The other one is the Dynavolt one, but I don't want to see that. I want to see a section looking down. So it's going to be something like this: the plate, the H, and the 2 box, the 4 box, sorry. So what are you going to show on that? You're going to show the schoolboy's beard, or schoolgirl's beard, I suppose. Let's not be sexist about it. You're going to have to show the dimensions to the bolts. You're going to have to show the weld symbol. And remember I said what you put here, you're going to have to choose yourself. You're going to have to call up the plate. You're going to have to call up the bolt and hole size. And you're going to have to call up the column. So that's quite a detail, so to speak. Okay? Only one mark for that. It's only one mark for that. So it's this one, and it's this one. It's actually a section. Let's call it AA. Okay. So one's a detail, which will look, you're just blowing up that. This one here, we're doing it as a section view looking down on the column. Now I've given you that column on the assignment. This here is being given to you. There's free steel members. Open up the CAD drawing, you'll find it there. Now you have a choice. The proper way to do it is to do a viewport at a scale of 1 to 5, two viewports. I would like to preferably see that and that on the one on elevation, the typical elevation, and one on the typical section. One detail on each. You can do a viewport which is 1 to 5, or you can simply copy. I'm going to allow you to do this. Copy that to the side and scale it up by 4, I think it is, because the other one's 1 to 20. Now that works fine in terms of your text types can stay the same, but your dimensions will be wrong. These dimensions here will be wrong, so you'll have to reset your dimension variables. Or you do a viewport, which blows it up automatically to the right scale, but your dimensions and your text and your arrows will be the wrong size. So you're going to have to change those for your section. I'm going to offer another half a mark if you want to do another couple of details as well, for those that are struggling for marks. So there's a bonus half mark if you want to do 2 more details for me.
Any other detail?
Yeah, but something different. Don't just do that on the other side of the truss.
Like say for instance, that detail there where the column and plate are fastened to the concrete.
Preferably one that's not to do with these.
Okay.
That is one that you might think about, but I would prefer that you did some of the truss. It's got so many different bits that that could be details.
With
Just plates and things.
as a question, you know, technical drawings, quite often you'll see the bolt and the concrete on an angle and the bolt perpendicular through the concrete to be fastened to, which is the fastening. Have you ever seen
The
that?
bolt goes down on an angle.
Yeah, in the cross section.
No. These dynabolts, by the way, I also got asked a question by one of the females in the degree class. They kind of look like this, where they split off at the bottom. And probably not that correct. When you tighten the nut on the top, these bits at the bottom push out against the concrete. They're probably a lot fatter than that. And it kind of spreads itself in the hole, and it won't come out again, sort of thing. There are other ways you can do that. You can use an epoxy resin glue of some sort, and you can preset the bolts into the glue and then put the plate down on top of it. Another way is just to put these plates in the concrete itself and set it into the concrete, and the plates underneath have got a way of gripping as well. I've seen that as well. So there we are. That's the only place you're going to find out about what you need to do for your assignment. Don't forget to take a snapshot of that. And lastly, down the bottom here, okay, we talk about inset protection, which is different to weather protection. So the common one in New Zealand would be probably the borer. It's not uncommon if you buy a house in Mount Roskill through to Mount Eden, an old sort of 1960s house, to find that bits of it have got borer in it. It's not uncommon for people to let off borer bombs, which aren't quite what they say they are. They're basically just a smoke thing you put under the house and you go away for the day, and it fumigates the house from insects. So borer would be the most common one, and I did rather like the name of this two-tooth longhorn borer, which actually goes for native trees. So I've put that one in my multi-choice question. All right, why not? It's the beauty of being a teacher. You can you get to choose the fun one. Not fun for you. So down here is the start of my H, the treatment for cannalisation, which protects against mostly the weather. And it gives some really good examples of where you would put the timber and the grade, and the H rating. And further down, it puts it in order. So you'll see here, you start off with H1.1 in terms of where you would typically use it, and it moves through to H3.1, which is external use but above ground, and it needs a paint finish, through to 3.2, which won't need any finish at all. External use. H4, it doesn't talk about H5, but H5 is, used to be called H6, doesn't anymore, it's called H5. It's what you put when you put piles in water. I don't know their life, but the treatment for it is pretty good. And that concludes basically the structural package of notes, all 57 of them. If you get bored over the lecture break, you can work your way through that, having a read. There's lots and lots of notes in there you can put in your drawing, if it's relative to the drawing. If you finish assignment 3 early and you want to do some work on assignment 4, doing the elevation, doing the details, as well as another way of advancing assignment 4, so it's kind of out of the way. You finish with me in week 13, that's it. No more study. No study, you've got the whole of study week to yourself. No exams, okay?
Only one more lecture, yeah?
There's only just the one. We have a lecture break. When you come back, then you have the revision lecture. Yep. So the good news is for most of you that are attending now, that'll be the end of it. You won't get to see me again for a while. No, don't say that just yet. We haven't. Not
Saw
a,
you
yeah,
yesterday.
as they say, the fat lady hasn't sung yet. She's just arrived at the Opera House. She hasn't sung yet. So, yeah, as far as the assignment goes, the usual story is up till 5 o'clock on next week. I'm in Wellington next week for quite a bit of it, because I'm on a thing where I'm actually talking about you guys and talking about people that did the course last year. And all the lecturers are getting together to see how we can make the course a bit better or worse for you guys. The sequels will start turning up probably at some stage during week 12. So, don't forget to fill that out. The best way, if you're not happy with the lecturer, is not to go on about things that are not to do with the course. So, for example, wears a funny blue jersey all the time or something like that. The best way is to put some constructive notes down about the course. If you like the past students and you want them to keep going, make sure you put that down, because otherwise, if that doesn't get promoted, they just disappear, because that's obviously a cost to Unitec. And it's a time to talk about the good, the bad and the ugly of the course as well. You don't have to do it, but I'd suggest that, especially if there's a course that you like better or you upsets you more, is a good idea to write something down. My advice for exams is to turn up to the lecturers' revision classes. Most of them don't just do it for a joke. They want their students to pass, so they cover at least 80% of what should be needed in that. And don't forget my one. Lab tonight, continuing on with your drawing only. So you've got the full couple of hours to do that, and the next day, bring your work in, and it'll just be the past student and me walking around and helping you with questions, okay? Try not to turn up to other people's labs, just turn up to your own one if you can. If you can't avoid it, well, there's plenty of room there anyway. All right. Any questions before you go flying off to your test? No? Yeah. All right, well, make sure you've got plenty of handkerchiefs after you've done the